Now let's look at the second example in this topic. The problem is called the voting for captain, and the key concept that we are introducing in this problem is a vector. Um, so here's the problem statement. We have a team of n players, and they are numbered 1 to n, and they are voting for the captain of their team. So each player can send in one vote, and the vote will be between 0 and n, where 0 means that the player actually didn't vote, or writing an invalid ballot, or whatever. So the other numbers representing the vote is for that particular player. And we want the outcome by majority. So meaning that the person who have at least half of the players voting for him or her will be captains. So then there are different possible outcomes. One of them is the listed here under the second. Is there's one player receives the majority vote, so defined as at least half. So if n is odd, this will means that you need to round up. So then that player is the captain. But it's also possible that when n is even, there are two players who each receive half of the vote. So everyone voted, and they all voted for these two guys, and they each receive half. So they are exactly the same number of votes. They exactly have the support of half the team. So in that case, we just call them co-captains. So then, obviously, there's also the case that no player receive a majority of the vote. So then, in this case, let's assume that there's a runoff election or some other mechanism for deciding who will be the captain. So then what we want to do is to identify the candidates for this, let's say, runoff election. So then what we want to do is we want to identify a group of 2 or more players, and they are the ones who receive the more votes than anyone else who's not in the group. And we want the smallest such group. So essentially, what you can think a little bit about what this means. So we will return to how to implement this later. So this case is no player receive majority, and then there are 2 or more players that we can identify as they receive more votes than anyone not in the group, so then they can be the candidate for the runoff election. So I have a question here, which is there another case? Because in fact that when I first created the problem, I thought these are the only cases, and but then I run the code against some test data I created. I realized there's another case that I didn't explicitly consider. So what is it? So the other case is that there's only one player who received any vote, but it's less than the majority. So then we cannot we don't have more than one candidate to do a runoff election, but that player is not doesn't have majority and shouldn't be captain either. So this basically happens that we have too low a turnout. So in some sense, maybe the team doesn't deserve to have a captain if they don't really care to vote for it. So that's the fourth case. So let's look at some samples. So first sample, we have 3 players. They vote 3 to 3. So then that means player 3 receive 2 votes. So player 3 is the captain. So this is what we want as output. For sample 1, we have 6 players. 3 voted for player 1, 3 voted for player 2. So then player 1 and player 2 are co-captains. So for sample 2, this is the case that I mentioned earlier. We have 9 players. 5 of them did not vote. The other 4 voted 9. So then in this case, we have a single player who received any vote, so it doesn't make sense to do any additional election, but also we don't have a captain. So it's no captain due to low voting turnout. And sample 3, we have 9 players, and these are the ones they voted. So then the candidate for the next round is 1, 2, 3, 4, and we ask that to be in the order of their player ID. So in fact, you can argue this is a fifth case which should be handled differently because no, okay, let's say it's not. So because in the first vote we have 9 candidates and now we have 4 candidates. Um, so maybe a runoff election with this 4 makes sense. So this is last sample. We have 10 players, and this is what they voted for. So note that we have one player 3 who received 3 votes, and he actually received the highest number of votes from among all players. But that's not majority. So therefore, these 3 will go to the next round. But we also need more than 1 players. So we need 2 or more. So then we can include player 2 who received 2 votes. But we have to also receive player 4 because otherwise 2 does not receive more than more votes than 4 does. And also just naturally it doesn't. It's not fair to include one of these 2 and 4 and not the other, right? So we include them both. So this is the candidate for the next round are 2, 3, 4. So how do we solve this problem? So this is an interesting problem, and if you know the idea of arrays, you can try to solve this problem. So I encourage you to try to code it up and try to get it work before going on. But if you're not familiar with array or you don't want to try it, then that's perfectly fine as well. So okay, so in general, when we try to write code that's a little bit more complicated, we want to break the task down into steps, right? So to handle a big problem, we break it down into smaller problem and then solve them one by one. So in some sense, that's abstractly that's what the programming about. It's suitably breaking down the overall task into smaller steps that can be implemented using code. So these are the things that I think the step that sort of naturally come to my mind, which I think hopefully should be natural. The first step I think should be natural is, well, we first need to count the vote, right? So we have to count how many each player received how many votes. So after doing that, then there are actually different way to do it. But to me, what I want to do is to figure out the highest number of votes received by many player. So because that determines it's a major factor in determining which cases we are in. Because if that number turns out to be majority, so greater than equal to sort of at least half or more, if that number turns out to be half or more, then we just need to figure out whether we have 1 player receiving that number or 2 players, and then who are they, and to sort of output that information. On the other hand, if that is not majority, then we need to figure out how many players share the highest vote. And if that number is 1, then we also need to consider the second highest number of vote and who received that. So we'll figure out how to deal with these logics later. But now first, let's see how do we even count the number of, how do we store the count of the vote. So counting the vote seems simple enough, but the question is how do we store it? So essentially we can use an array, right? We can use an array which stores the number of votes received by each player. The only problem is we don't know the size of the array because the number of players is given at the input n. So we need to read that and then we declare the array. However, we cannot declare an array with a variable size in C and C++. So an alternative is we know the maximum possible value of n in the problem. So then we can just declare an array that's big enough to handle that. So that's one way. So you can solve this problem using this kind of statically declared array without using the concept of vector. But more naturally, and the better a better way to do it is to use dynamically sized array. So these are the arrays that whose size, when you create it, you can tell how big it is, and also they also have the ability to change its size dynamically. So you can add additional element to the array when you during the program execution. So that is a functionality we actually don't need for this problem. For this problem, all we need is when we declare the array, we want to tell how big it is. So while at the time of us writing the code, we don't know how big the array needs to be because we don't know what is the value of n. So this is the code for sort of declaring the array and then counting the number of votes received by each captain. So let's this line of code in red, we're going to break this down in the next couple of slides and discuss them in details. So for now, let's just view this as declaring an array of size n plus 1. So the array's name is count, because we are counting the number of votes received by player 1 through n, and because the array index starts at 0, so I declare the array to be size of n plus 1. So then I can directly use the player ID as indices into the array. I don't have to sort of subtract 1. So this for loop counts the number of votes received. So it will read in each vote, which stored in a variable cap. So the vote for captain from each of the players. If cap is greater than 0, that means it's actually a valid vote for one of the players. So then we will increment the count for the corresponding player. So this for loop counts how many votes received by each player. Now let's try to understand this code in red. So to understand that, we first need to introduce some concept, classes, templates, and the standard template library. So class is it's an important concept in programming. It's sort of the fundamental concept in object-oriented programming, which is a key feature of C++ and Java. So C is not a object-oriented language, so it doesn't have the notion of a class, or at least a sort of full-fledged notion of a class. So the concept of a class is a lot of times we will have a certain data structure. So for example, this dynamic size array, and then we have a whole bunch of operations that we want to provide. The programmer may want to apply to this data structure. So the code for implementing this dynamic size array have to support those operations. So this operation for array may include the add an element, remove an element, getting the number of elements in it, and in fact many more. So there are many operations when you that programmer for implementing this dynamic size array want to support. So this code for this operation and the underlying data structure, they are in some sense related. So then they are grouped together using this concept of a class. So you can view a class as a bunch of underlying data storage together with a list of operations that are allowed on those data. And the very important concept in class is this notion of encapsulation. So this you can hide some part of your implementation to the usage of your data structure, your concept. So for example, for the dynamic size array, so I may use some kind of array to store this data. But I can hide this variable, this array variable for storing this data, and only provide the interface of adding element, removing the element. Because when I support a dynamic size array, if I add more elements than the array I already have, I need to sort of allocate a new array. So there's functionalities have to happen when on some of these operations. So encapsulation means that I can decide which part of my data and code is visible from outside and which part is not. So the benefit is then for the hidden part, I know which code can touch it. So something that's really bad in programming is given a data, if it can be touched in many places, then it's really difficult to reason about what the program do. So by hiding some of the data, so that you know only these couple of pieces of code can touch that data, then you can reason about what must happen in the data and make sure the program is correct. So encapsulation essentially hides something and only reveal something to the outside. Typically, these things that are revealed to the outside are functions that can be called. So that's the notion of class. We'll probably return to the concept of class later in the course, but I think for now that is enough. And when we implement a class, sometimes we are going to want a similar class with a sort of slight variation. So for example, if we need a dynamically sized array, so array whose size may change during runtime while we add more elements to it, we will need a dynamic size array. Sometimes we need dynamic size array of int, sometimes of double, of char, of bool. So in a sense, the logic for dealing with manipulating of the data is similar. It doesn't matter whether we are dealing with int array, double array. The code should be similar. However, the code are not exactly the same because we have to put data type for the variable. So in order to support that, we have the notion of template. So a template can be viewed as you write code, but some of the data type, and in fact, more generally, template, you can have things other than data type, like constant, that are not decided yet. But for now, let's just focus on when I write a piece of code, some of the base type is not fixed. However, all of the current, so if I'm doing an int array, then all of the element will be int. If I'm doing a double array, all the element will be double. But when I'm writing the code for this dynamic size array, the type is not fixed. So I use sort of a variable that can take value of these basic types in my code. So then this is a template. So then when other people want to use this piece of code, this template code, then they need to provide underlying type. And then the version of the concrete code is created and used. So you can view what happens as essentially the data type you are provided is used to replace all the place where this type variable occur in your code. Then you have a concrete version of the code. So in that sense, you can view template as a almost like a macro. So maybe it's a macro on steroid, but it's not implemented in the same mechanism. But conceptually, you can think of template as a macro mechanism, so that enable you to create a version of the code where the data type is made concrete. So then C++ has a library called the Standard Template Library, STL. So this is a set of C++ template class that provide the common data structures. So these are some of them. They are very useful, very powerful. For this course, I think we'll probably use only vector. So I haven't totally decided. Maybe we will talk about set toward the end, or maybe not. Most of the course will be vector is sufficient. And in case if you are familiar with Java, then vector in C++ is very similar to Java's array list. In fact, Java, at least older version of Java, have a class called vector, which is essentially array list with additional support for synchronization, making it slower. But because the way vector was originally designed didn't do synchronization quite right, so now it's deprecated. So you're not supposed to use vector. So you use in Java. So Java's array list is more or less equivalent to C++ vector, and in Java array list is known as the generic. So that's essentially the same concept as template. Okay, so with those basic concepts, now we can try to break down this line of code. So vector is the name of template class provided in C++ STL. So we need to include the header file in order to use this vector class. And this syntax of a class name and then less than sign, and then something in the middle followed by a greater than sign. So here I have a type name in the middle. So this syntax is instantiate a class name by providing a concrete type name. So just like here, vector int, we are saying we want to use vector, and we want to use a vector of int. So, and this is a data type. So vector by itself is a template, but after we're providing int, this is a concrete data type. And count is a variable, and the count is a variable of this vector int data type. So this is a data type, a variable name, and then this equality basically is a initialization, providing an initial value for count. So, so we want to create a value of this type in order to initialize this variable. And this is done using a constructor function. So this looks like a function call, right? So this vector int looks like a function name, and then with the 2 arguments. So this is called a constructor function. So the red part is the function call. And the name of the function is the same as the data type. So that's the feature of a constructor function. So it has the same name as the data type, and it will return a value of that type. So essentially what we call a function providing these 2 arguments, and then we get a vector int value, and then we assign that to count. So that's what this line does. And one class may have multiple constructors. They can take a different number of parameters and a different type of them. So, and the compiler, based on the type of the argument, will be able to figure out which of the constructor function should be used. In C++ 11, there are 6 types of constructors for a vector. And here we will start with just a few of the variants. So each type actually has multiple instantiations. So I think the 3 listed here, probably the first one I think is known as the default type. Then the next 2 are actually the same type. So we can, if we don't provide any argument, we'll create an empty vector. So it starts with 0 element, and then dynamically we can add to that array. So this is creating an array of 0 element. So if we provide a single integer argument, then that argument will be interpreted as size of the array we want. So this will create a dynamic size array with starting with the s element. If we provide the 2 values, the first one is the integer, and the second one is the same type as the base type. In this case, it's also int. And then that means we want to create a vector starting with s element, and each of them taking this initial value val. So so here in fact there's an alternative syntax when you initialize the variable. So the second line here is equivalent to the first line. So this may look a little bit strange, because why does this second make sense? Because this second, it looks like a function call, right? It looks like count is a function name with 2 arguments. But count is not a function, it's a variable. So the reason that this makes sense is you can view this essentially as a shorthand for the previous one. And it makes sense because here we are in the context of declaring a new variable of this type. So then when we have a variable here and we have this function syntax, the only thing that makes sense is we are trying to assign an initial value to this variable. So if it's a function syntax, then that means we want to call some function. Then the only function that makes sense is the constructor. So therefore, the compiler look at this, will know, hey, I know what you want to do is to call the constructor with these 2 arguments and then assign the value to this variable. So that's why this shorthand sort of logically makes sense. Yeah. So that's it for now. And then next video we will return to the problem to use a vector to sort of solve the problem.